Hey folks, it's Tom, your frugal prepper. So I got this digital clamp meter. I'll put a link for this down below. I think it was about $40 on Amazon. And this is an AC/DC clamp meter. The box is kind of weak. Just like this is an AC and DC clamp meter too. This is the Tac Life CM101A. You can get this pretty cheap on Amazon as well. I think back when I got this it was like 20 bucks, but it might be a little bit more, and there might be a little newer version of it out there now or something. But this has been a great little meter, actually. So this is also a digital clamp meter, but it has a unique feature. It comes with these test probes. Let's take a look at these. And these feel a little bit nicer than these test probes, actually. They feel a little softer. See how they do in the cold. You know, that's one thing when you're a mobile mechanic in the wintertime, you really want some nice, super flexible leads. And these aren't super flexible. I mean, they're okay at room temperature, but I can tell you at freezing temperatures they're going to be kind of hard to deal with. Comes with this temperature probe, which I guess this can be handy if you're trying to read a temperature. I don't carry an infrared thermometer with me mobile, so I guess I might use this at some point. It's kind of chintzy there. Looks like it's a solid core phone cable wire or something. That's kind of chintzy, but oh well. Comes with a battery. Comes with the meter. And these look okay. I'm trying to see if there's a cat rating on these. I don't really care for automotive use if they are cat rated or not. I don't see a cat rating. So yeah, but they look pretty decent. They look like pretty decent little probes. Not super fine point, but fine enough. But you know, we like those really fine point probes in automotive. Comes with this one instruction sheet. So a 4,000 count meter, it says. That's good to know. You know, this one here is actually a clone of a Fluke, and it's a cheap Chinese meter, but this is 10,000 counts or 9,999 counts. This is actually a really nice little meter. I mean, it's got all the specs here, range, accuracy. So there's a few things that I want to know about it right away. And at first, I guess I'm going to have to find a small Phillips screwdriver so I can put the battery in this guy. It is quite a bit bigger than the Tac Life meter. Boy, it's quite a bit stiffer here too for that clamp. But yeah, it looks like that's maybe for the temperature. These two for the temperature, and this is for the common. This is for voltage, ohms, and hertz. It's got this sticker over it. Take that off. So the reason I like this meter is this is supposed to connect to your phone with Bluetooth. I don't know how yet, but I got my iPhone, and we're gonna try to make that happen. Okay, I got a knife here. I'm gonna try to get this screw out with that. It's not a snap-on knife either. Okay, now it's got a battery connector here. Kind of short battery connector, kind of a cheap little battery connector, but hey, at least it comes with the battery, right? Whoa. Alright, sorry about that, you guys fell over. Alright, I think you guys had a little too much to drink. Alright, there we go. So I think that's DC voltage. So let's just take a reading of the impedance of the DC voltage meter here. Oh, these probes that came with it don't really fit it. They don't fit very well. Ooh. Yikes. Okay. So 5.3 million ohms. So yeah, I mean 10 million is better, but it's around 5. It kind of fluctuates between 4.8 and 5.3. So around 5 mega ohms of resistance. Not bad, not bad. 10's always better, but these days, you know, scopes sometimes they're 2,000. So you know, 5 something I can live with. And then let's see how much voltage it does on its diode tester. And so select. What the heck is going on here? Do I got a bad test lead? Man. Okay, my test lead wasn't making contact there. So here's what I want to do. It's kind of hard to read this, I think, but what I want to do is put this on the diode check. So I'm going to hit select, and it looks like that's the diode check. So now I'm going to measure the voltage with the other meter here. And so we're getting 1.496, so about 1.5 volts. That's kind of a minimum for a diode checker. I'd rather see that more like 2.5, but I can live with 1.5. And so now let's check the resistance, which the polarity will be reversed on the resistance. 125 millivolts, and I can hit different ranges. 145. That's almost a half a volt. Yeah, so about half a volt is all I get on the resistance. So really not going to do too much injection with the ohm meter, but the diode checker at 1.5 volts could work. Not necessarily ideal. So like you take this meter and we put it in diode checking mode, and first of all I can see this meter so much better. And now we'll take this one, we'll put it in the voltage mode, and it's set for auto ranging, and then we'll measure the voltage off of this meter, and we see what are we getting there. 3.2 volts. So this one puts out 3.2 volts on a diode checker. So this is the one I would use to inject a signal into something that uses a 5 volt ref most likely. So what happens if we scan that with our phone? Okay. It's going to take us out here to allcare.net. And it says click to download. We'll click it to download it. Okay. Intelligent clamp meter app. Okay, it's downloading it. Oh, I gotta do my fingerprint. Alright, it's downloading the app. So then we're gonna see how that works. It's done downloading, so I click open. It says intelligent clamp meter would like to use Bluetooth. And so we'll say okay. Alright, start. Hey, it's reading it. Check that out. Yeah, that's what it's reading too. 3.269 volts. Nice. It kind of sucks that it keeps doing that, but it does kind of take it a minute. So let's try the data logging, or here's a graph. Okay, here's the data logging. So I'm just curious how fast that will update there. Looks like it's about tick tock, about every half a second or so. That kind of sucks. It's really hard to see. I have to play with the settings and see what I can do. Here's data sampling. Oh, sampling rate. So it's set for 60 minute, 120 minute. Let's move the sampling rate down to 1 minute and see if that gets us any faster time. It's not even showing me that. Let's go back to settings and move our data sampling up a little bit. Maybe that's the problem. Oh, whoa. Oh, crap. Boy, that's pretty slower. So let me go to settings and move it all the way up the other direction then. Oh, that makes it faster. Now check that out. Wow. So it'll be interesting to see what we can do with this meter. My first impressions on this meter are that it's cheaply made. It lacks good features. It doesn't default to certain settings that it should default to. It's really hard to tell this pointer where it's at. Just the temperature gauge is very cheaply made. It's a really unique idea to have a Bluetooth app, but the app, again, it needs to have a slightly faster sampling rate, I think, and you need to be able to change this color. You can't see this little thin red line on this blue background at all, like I can't. So that makes it kind of useless if you can't read the graph. Yeah, I mean, I would say this is probably a skip. In fact, this, we'll play with it a little bit more tomorrow, but this may just go back to Amazon. I don't see right now where it's really going to be worth $40. I mean, it might have been if you could, mess with these graph settings a little bit and change that, and then it would definitely be worth it for parasitic draw testing. But, like, I can't even read across the bottom what this lettering says. Like, maybe if I went and got my magnifying glass, I could read what those letterings are down there. But the red on the blue with the bad font, can't see it. Can't see it. And you can't turn it sideways, so it only works in this direction. Alright, so I got the map sensor brought up here. We're at 13.92 psi with the engine off. That's nearly atmospheric pressure, right? I mean, I'm at 14.7 or whatever should be like atmospheric pressure, I believe, at sea level, and I'm about 1,000 feet above sea level. Maybe a little more than that. So we'll start it up here, and we'll see. It comes down to 14 or 5.5. Okay, 5.5 psi. If you can see that, I don't know. There we go. And as I hit the gas, it'll raise pressure. Yeah, and then of course on the decel it loses pressure. It comes back to about 5.66. Okay, so our map sensor is working correctly, but what I want to do
is show that we can, let's say we had a map sensor stuck high or low, how we can go out here and test that real quick with the multimeter. And this will work on just about any map sensor. I think there might be some Ford map sensors that are digital, but any analog map sensor, this is going to work. And there's a couple things to know too, is that some map sensor designs have a resistor in them and some don't. And if it has a resistor in it, when you unplug it, the signal wire will go to 5 volts. If it does not, then you unplug it, it goes to 0 volts. But let's go take a look. I'm not sure what design this one has, honestly, but let's go take a look and see what we see. By the way, this is all scanner danner stuff that you can get on his premium site. I think this is under the 5 volt reference section. Alright, so what we're going to do is unplug the map sensor. This looks like it already has an aftermarket map sensor in it. These break pretty easily. So we're going to see which one is our 5 volt reference first. We're just going to back probe this red wire. And then we're just going to run our ground to a ground. Okay, so we'll just hook this up to the thermostat housing. And these probes on this meter are pretty stiff when it's cold out. They're not very good. Okay, so we'll hook this up to our ground. Like so. And then we're just going to measure this and see which one of these has 5 volts. So I'm going to take my meter, put it on voltage. I think that's voltage. I'm going to hit the select button until it says DC. AC, okay, it doesn't say DC, it just says AC and then not. It doesn't say AC for DC. So let's see. And there's our 5 volts. That's our 5 volt reference right there, that red white wire. So now we want to see, do we have 5 volts on a signal wire? We have 0 volts there, and we should have 0 volts probably here. Yeah, like 3 millivolts or whatever. And pretty much no voltage here. Yeah, 4 something millivolts. So what we want to do is find out which one of these wires is our signal wire. And the way to do that is to watch the computer. And then we're going to take and we're going to inject a voltage into it. So you could take a test light from the 5 volt reference to the signal wire. It's probably okay. But the other way you can do that is by just using the diode tester on your multimeter. So what we want to do now, let's just go ahead and disconnect this, right? And so we're just going to go ahead and move this to diode test, which is this one right here. Then we'll hit our select button. Now we're in diode testing mode, right? And so now we're going to leave our ground lead on the ground. Come on, meter. This piece of shit. This meter is kind of a piece of shit, I'm telling you. Don't buy this thing. I am sending it back. But now we can go ahead and inject some voltage here in our yellow wire. And so now we'll be injecting that, however many volts it was, 1.3 volts. And we should see, if we're still connected here, 5.37 psi and 2 psi, 1.45 psi. Now if your meter will show voltage, you would know. So no signal gives me 1.45 psi. I go ahead and inject my voltage in here and I get 5.3 psi. So that's my signal wire. So that tells me that everything's good, right? I got a signal ground here. When I probed that with my meter, that gave me a ground, and I'm actually injecting about 1.5 volts in here. So what I'll do is grab my other meter that puts out 3.5 volts, and we'll see what that one reads. Okay, so this one will be a little easier to see too, what I'm doing. Okay, so basically I'm on voltage right now, right? And so I've got my black wire is hooked to the ground of the car, and I'll turn on the light here to help you see this a little better. Maybe. We'll tuck that down here. I hope you can see that. I think you can. Okay, and so now I'm just going to take and hook this up to my positive probe. If I can get it up here. Again, these probes aren't real flexible either. It's about freezing out here right now. It's about 32 degrees. It's not too bad. And so we'll probe this red white wire on the voltage. Yep. And so I got 5.02 volts. Okay. And so I come down here and I probe this wire with this wire unplugged, and I get basically ground, you know, millivolts. So that's basically a ground. So that tells me that I don't have a resistor in line, and I'll show you what that means here. And then I'll probe this one. It also gets the same sensor ground. I know now that this is sensor ground, but let's say I didn't know which one of these was my signal return and which one was my sensor ground. Well, what I would do, switch my meter here over to diode test. And I have to hit select, I guess. Okay. There's my diode checker, right? And so now I can probe my sensor ground, and I'll see that this value doesn't change. It stays at 1.45 psi. But now if I probe my signal wire, I'm actually injecting that 3.5 volts back to the computer, and I got 10.15 psi. So that's the difference between 3.5 volts and 1.5 volts. Either one will work. I prefer to use a little higher voltage, but that's one way you can quickly identify what's going on with your map sensor, what's sensor ground, what's signal return, and what's your 5-volt ref. So that's like I said, that's all Scanner Danner stuff from this 5-volt ref section of Scanner Danner Premium. He goes through this in detail. I'd suggest that you watch that video, but it's pretty basic stuff. But that's just a way that you can use a meter to quickly identify, determine, and test a circuit to know, now if I'm getting a bad reading from this map sensor, I know the integrity of my wiring is okay, the computer's okay, everything's okay. To this point, it is definitely a bad sensor, right, before I go and spend the money and replace that sensor. Alright, so what we have here is the computer, alright, and then we're going to have basically a 5-volt reference coming out of the computer, and we're going to have a signal wire right here, right, and we're going to have a sensor ground coming out as well. And so this is our signal return, also sometimes called low reference on GM diagrams. Anytime you see low reference, that's a signal return wire. Alright, this is our 5-volt ref. Right, and so what you have here is you can have basically 5 volts on this wire, right, and then you'll have 0 volts on this wire because this is your ground, signal ground, right? And then what happens to this wire when you unplug it? Well, normally this would just, you unplug the sensor right here and this will go to 0 volts, right? But you can have a circuit that has a resistor in it right here, right, and basically uses that resistor so that when you unplug it, it'll go to 5 volts. But when it's plugged in, it'll read 0 volts. So that's just something to keep in mind. This GM does not have that. but some cars do. Anyway, that's how you can test the map sensor with a DVM and fully test the integrity of the wiring to know whether you have a bad map sensor or not. And that takes 5 minutes tops, and you have the diagnosis done. You didn't have to break out any wiring diagrams, you didn't have to break out your all data, you didn't have to go and look at a bunch of different stuff. Just knowing how that circuit operates, you're able to inject that 5 volts into it. And that works for basically any sensor that has a signal return that comes off of a 5 volt reference. And so you're good, right? As far as using the test light from the 5 volts to the signal wire, I think that's acceptable. But again, you want a low amperage test light. You don't want to have a big headlight bulb test light, because amp and a half is all you get on your 5 volt reference. So it won't take too much to short that out. Most of them have really good short circuit protection, but you don't want to rely on that. You don't want to pop a computer. So there's some other interesting things on Scanner Danner's websites, like using your fingers, right? I guess I could show you that too, but you can use your fingers to inject a signal as well. So anyway, we'll do that on another video maybe. I don't want to give away all the Scanner Danner secrets, right? like it's not fair for me to learn something on the channel then come here and tell you guys about it. But at the same time, I get excited when I learn these tests, and I can do that. So this meter is going back. I didn't show a video on it because it was a miserable failure trying to do a voltage-based graph off of, or I guess a current-based graph off of the amp clamp to do a relative compression test. It's not happening. It doesn't have a fast enough response time. And even if it did, you can't read the graph with that thin, tiny red line on that blue background. It's just horrible. In general, the things I hate about this meter are that these test probes are very unflexible as it gets colder. The display is very hard to read. It has no backlight. The little things across the top that tell you the modes are almost impossible to see because they're partially hidden under the black part, like the display is not centered right in there. This little guide right here that tells you where the meter is pointing is really hard to see. I mean, the clamp part seems to work okay, but in general, just really a crappy meter, crappy design. Like all the defaults are wrong. It always defaults to AC wave instead of DC. Just things that my Tac Life meter don't do. And the Bluetooth app doesn't work good enough to make this worth keeping for 40 bucks. So I am going to take my battery back out of this and send it on back today. But yeah, I mean, if you needed a really basic meter, I guess this is an okay one. I would rather see you get the Tac Life or the newer version of this Tac Life. I'll put a link to it down below. But this would be the meter to get. It's a really good meter. It's done really well for me. I've had this about 2 or 3 years now, and I've used the crap out of it, and it works great. Or that other Fluke meter, if you don't want the amp clamp part, is a great meter as well. I'll talk to y'all later. This is Tom, your Frugal Prepper.